Okay, good morning students. And today we will discuss about the physical properties as well as chemical properties. In the previous class we completed preparations of alkyl halides. Now we have to discuss about the physical properties of alkyl halides. See, the very important concept we have to understand carefully, physical as well as chemical properties. So first point I am telling here, regarding alkyl halides, the boiling point and as well as density. How relation with force of attraction? Directly proportional. Why? You suppose you take two particles, there is a very strong force of attraction. Then if you want to evaporate that liquid, required energy will be more. Same thing, if you take one material with strong force of attraction, closed packing means density will be high. So that's why boiling point and density is directly proportional to which one? Force of attraction between the molecules. That force of attraction is directly proportional to molecular mass or molecular weight. Are you agreeing on it? Yes. You take a simple molecule, small molecules taken. You take them and then automatically what happens? They are far away from each other. Why? Because lightweight. You take a big molecules taken. What happened? Because of mass, they are closely set together. That's why as the molecular mass is increasing, force of attraction increasing. Force of attraction increasing, both the boiling point and density will be also going on increasing. How we will ask in the competitive, you see carefully. For example, he given CH3Cl and he given CH3CH2Cl he given, which has more boiling point and more density. This one, why? Yes, more molecular mass. More molecular mass means heavy particle. Heavy particle means closely packed. Closely packed means density will be high. If closely packed, if you want to convert them into gas, required energy will be high. Just this is only question is asking. And you see, I will ask you one more question. For example, CH3Cl and CH3Br and CH3I. What is the boiling point or density order? See, in all these, methyl group is common amount. Now we have to go comparison with respect to halogen. Fluorine, chlorine, bromine, iodine comes down, atomic mass and atomic number will be going on increasing. Anyway, it is a heavy particle. Due to heavy particle, so molecular mass will be high. Molecular mass is high, force of attraction high. Force of attraction both will be high. That's why the order will be coming like this. This is an important thing. Next point I want to tell you one more thing. If you take alkyl halides and relative molecular mass, almost similar molecular mass having alkanes, and which is having more melting and boiling point as well as density. Alkyl halides are having more boiling point and more density than corresponding alkanes. Just I will tell you one thing. If you take for example C2H5Cl is there. If you take relatively is nothing but which one? C2H6 will be there. It's a corresponding. Means almost molecular mass will be same, even though this is having high boiling point and density. Why? You have to observe very carefully. In this, which bond will be there? CC bonds will be there and the CH bonds will be there. Both are which type of bonds? Non-polar bonds. Means almost alkanes are acting as a non-polar molecule. Between non-polar, what bond will be there? So van der Waals forces will be there. The common force is nothing but van der Waals force of attraction will be there. It's a universal force will exist between any two metals. But if you come to here, something going on special. Here also CC bonds is there, CH bond is there, and also CCl bond is there. What is the special of CCl bond we discussed in previous class? Okay, it is becoming partially negative, it is becoming partially positive. Due to this one, what happening? The alkyl halides are having which nature? Polar in nature. Yes, they are acting as a dipole. Dipole attraction is stronger than van der Waals force of attraction. That's why always alkyl halides are having more boiling point as well as density than corresponding molecular mass having alkanes. Even though molecular mass will be same, but always alkyl halides should be having high boiling point as well as high density. Why? Because reason they are acting as a polar, these are acting as a non-polar molecule. I will give you one more explanation for you. Observe very carefully. In case of isomers of alkyl halides. What is the meaning of in case of isomers of alkyl halides? Just I will give you explanation here carefully. For example, I am taking one molecule. It is nothing but C5H11Cl. For this one, pentyl chloride. So first of all, I am writing the first molecule is nothing but the straight chain CH3, CH2, CH2, CH2 and Cl. With the same formula, I am writing one more molecule CH3, CH and CH3, CH2 and CH2. Sorry, 5 carbons. No, one more will be coming here CH2 and Cl. So then we are getting like this. I am writing one more isomer, means same formula but something will be different, like China position something. I am giving one more molecule CH3, 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 Cl. Sorry, CH2, Cl. Yes. Okay, sir. I will go according to this concept of all are having same formula, same molecular mass, then they are having same boiling point means meaningless. Why? Some special is here. In case of isomers, you check it clear. All molecules are having same formula even though they are not having same boiling point. Why? Because in first molecule it is becoming like a which one? Straight line molecule. If you take this liquid, what happening? All molecules are having like that straight line. Due to that straight line structure, what happening between the molecule contact area will be high. If contact area will be high, force of attraction will be high. If force of attraction will be high, boiling point as well as density will be high. But comes to second case. So because of one branch, what happening? It is becoming like elliptical shape, not straight line. Because of one branch, it is becoming like elliptical shape. Compared with straight line, elliptical shape having less contact area. You see like this, one more molecule here. This contact area will be less than your contact area. Contact area is less, automatically force of attraction will be less. Force of attraction will be here less. Now comes here, this body is almost like a spherical shape. Compared with elliptical shape, in case of spherical shape, contact area will be still less. Then automatically force of attraction between those liquid molecules will be very less. Force of attraction will be very less. What happening? The boiling point and density will be also very less. That's why simply you are telling one conclusion here. In case of isomers, as the branches is increasing, here only one, here no branch, here one branch, here two branches is there. So in case of isomers, as the number of branches is increasing, the molecule is becoming a spherical shape. As the molecule is becoming spherical shape, the contact area between the molecule will be decreasing. Automatically force of attraction decreasing. Force of attraction decreasing, boiling point and density will be also going on and decreasing. That's why what is the highest? This one. After this, this one. Least is this one. So can we conclude one conclusion here? In case of isomers of alkyl halide, the boiling point and density is inversely proportional to number of branches. First molecule no branches, one branch, two branches. The branches is increasing, melting and boiling point and density will be decreasing. So number of branches or nothing but number of substrates in the molecule. Very simple thing. Okay, last point and very important physical property. I am telling, listen carefully. Alkyl halides are insoluble in water. Alkyl halides are insoluble in water. Very good question. Why alkyl halides are insoluble in water? Means you take chloroethyl chloride and water, you mix them, they are becoming like two layers. They should not mix together. Why? Just I will tell you reason. If you take alkyl halide, representation will be Rx. You take in water, formula H2O. it want to dissolve in this one. It's not possible. Why? If it want to dissolve, this alkyl halide has to be done two things. What is that one? In water, first of all, between water molecule and water molecule, what will be there? Hydrogen bond will be there. Okay, now alkyl halide want to dissolve in this means it has to be break the hydrogen bond. That much capacity not having by alkyl halide. And one more thing, one more reason also made possible. So this alkyl halide has to be form hydrogen bond with the water molecule. It is also not happening. It is unable to break the hydrogen bond which is present in the water molecule. It is unable to form the hydrogen bond with the water. Automatically there is no interaction between water and alkyl halide. That's why they are like a separate liquid. And sir, why happening like this? For example, you take an alkyl fluoride, you take it. Yes, this is nothing but H2O. Okay, you know hydrogen bonding character is what? Positively charged hydrogen atom has to be attraction with the highly electronegative element like fluorine, nitrogen, oxygen. Sir, F is possible and why it is not dissolving? Not dissolving. Why? You see here, even though F is there, it is not involving in the hydrogen bonding. Not involving in the hydrogen bonding means not involving in the solubility. Why, sir? You see, alkyl chain. Alkyl chain means CH3, CH3, CH2 like that big chains will be there. You know special of alkyl chain? Alkyl chain is having a special nature, hydrophobic nature. Hydrophobic. Hydrophobic means what? Water phobia. Water phobia means while seeing water it going back. Means it's always repelling water. So hydrophobic means is nothing but water repelling nature. Water repelling nature. Due to this water repelling nature, even though fluorine want to attract, but alkyl chain is pulling back, then there is no bond formation between alkyl halide and water. That's why even though fluorine will be present, it is unable to form the hydrogen bond. That's why commonly we are telling alkyl halides are insoluble in water because two reasons. Alkyl halides is unable to break the hydrogen bond which is present in the water molecule, and they are able to form the hydrogen bond with the water molecule. Yes, it's a very important conclusion. What are the conclusions here? These are competitive bits. So generally in case of alkyl halide, the melting point and density is directly proportional to force of attraction, that is directly proportional to molecular mass. As the molecular mass of alkyl halides is increasing, the boiling point as well as density will be going on increasing. Let me give some example. Okay, generally alkyl halides is always having high boiling point and density than the corresponding molecular mass having alkanes. Why? Because these are having polar attractions, but these are having common attraction van der Waals force. Compared with van der Waals, these are strong. Strong means tight packing, high boiling point, high density. In case of isomers, what happening? Boiling point and density is inversely proportional to number of branches. Means here see, as the no branches. And as one branch, here are two branches. As the number of branches is going on increasing, the molecule is becoming like spherical shape. Whenever they are becoming spherical shape, the contact area between them will be less. The contact area is less. Force of attraction less. Force of attraction will be less. They can easily about reach this one. We can get. So alkyl halides are insoluble in water because they are unable to break the hydrogen bond in the water molecule, and they are unable to form the hydrogen bond with the water molecule. That is the reason they are like always separate liquids. Physical properties is completed. Now we are discussing about the chemical properties of alkyl halides. So first of all, how they are involving in the chemical reactions and which type of chemical reactions they are involving. First of all, if you take any alkyl halide RX, is it saturated or unsaturated? Alkyl halide, nothing but haloalkane. Haloalkane means is a derivative of alkane. Anyway, alkyl halides are under which compounds? Saturated halogen compounds. Okay, now saturated halogen compound means is it possible to involving in the addition or substitution? Saturation, no. Saturated means all are single bonds only around it. That's why no chance to breaking of bonds. Only we have to do substitution. That's why the saturated halogen compounds are involving in the substitutional reactions. Substitutional reactions. which particle is undergoing substitution? That is a concept first. You have to observe very carefully. First of all, I am taking one alkyl halide is nothing but C, H, and here, for example, X, whatever it is. Now, what is happening between here? Unequal sharing is going on. That because it is a highly electronegative, this is the relatively is less electronegative. This part, it is getting which charge? Partially negative charge. This carbon will get partially positive charge. Compare with CH and CX, CX bond is a weak bond. That's why that has to be breakdown. Means instead of X, someone has to be introduced. Okay, now I am taking a E plus electrophile I am taking and a nucleophile I am taking. You know very well, I think, electrophile. What is the meaning of electrophile? Denoted by E plus. Means what? Electron deficient. Electron deficient means they are always carrying which charge? Positively charged. And another one is nothing but nucleophile. Nucleophile. You will add in first year. Nucleophile is denoted by Nu minus. What is the meaning of Nu minus? Electron rich centers. Electron rich centers means they always carry negative charge. Now, out of these two particles, which is favorable for substitution instead of X? Yes, why? Because you see carbon after breaking this X, carbon is getting which charge? Positive charge. Positive charge is attached with negatively charged particle. That's why what happening? A nucleophile Nu minus is ready to substitute or replace that halogen atom. That's why it is attacking on this carbon atom while breaking or while going halogen atom away. So whenever it is involving in the bond formation with carbon atom, this bond will be totally breakdown. Then we are getting which compound we are getting? Nu you are getting, remaining hydrogen bonds will be as it is. After that, which particle totally coming outside? X minus. Now, which particle is undergoing substitution? Nucleophile instead of X. That's why it is always alkyl halides is involving in the which type of substitution reactions? Nucleophilic substitution reaction. Once again, the whole chemical properties is going according to this concept only. In any alkyl halide, if you can take carbon and halogen, they are having polarities. Because highly electronegative, this is highly electropositive or less electronegative. Due to that reason, carbon getting positive charge is always favorable for attacking of a negative charge, which is a negatively charged reacting species, nucleophile. Whenever nucleophile is attacking on this carbon atom, immediately this C and halogen bond will be breakdown. After that, this bond will become strong, this bond will be totally breakdown. I showed that one. Finally, what happening? This halogen atom is replaced with the nucleophile. That's why it is calling as a nucleophilic substitutional reaction. Fix in your mind, alkyl halides is participating in the nucleophilic substitutional reactions. Now, we will see some examples for this one. This is just for idea purpose. I told that. Yes, you see. Under this one by one we are discussing. First of all, it is a reaction with aqueous KOH. Yes. What is the meaning of aqueous? KOH dissolved in the water. That is the meaning of aqueous KOH. Just you see carefully. Very important competitive bit this one. Okay, you see carefully. Alkyl halide will be involved in the reaction with which one? Aqueous KOH. We are getting a ROH we are getting. What is the meaning of OH function group? OH function group means is calling as alcohols we are getting. Alkyl halides will be treated with aqueous KOH we are getting corresponding alcohol. How it is happening like this? Just I will give you one example. CH3Cl will be treated with aqueous KOH. What happening at here? It is becoming like K plus OH minus. This K plus will absorb Cl minus. Is becoming like which one? KCl. After that, what happening? OH minus will be substituting that position. Then we are getting which one? CH3OH. What is this one? Methyl alcohol or methanol. Okay, but just once you see how is the mechanism is going on. Mechanism means how the product transmission is going on. First of all, KOH is breakdown like K plus OH minus. OH minus itself is acting as a nucleophile Nu minus because negatively charged reactive species. Okay, now what happening? CH3 Cl will be there, but C and Cl bond is polar bond. It's becoming like partially negative. It's becoming like partially positive. Which side is favorable for attacking of nucleophile? Positive side. So OH minus will be attacking on this positive side. Whenever it is involved in the bond formation with this carbon, this bond will be totally breakdown. Okay, then what we are getting? CH3 OH will become strong, and which is coming outside? Cl minus. That Cl minus will be coming outside. After coming Cl minus outside, Cl minus and K plus is again becoming like KCl. See, once again I am telling these mechanisms is not required, but don't do the things blindly. Understand and practice. How it is happening, you should come to know. Whether you are practicing or not, but should understand. This is important and enough. Okay, like that, whenever you take any alkyl halide reaction with aqueous KOH, we are getting corresponding alcohols we are getting. Just I will give you one more example. You see, for example, C2H5Br will be treated with like aqueous NaOH. Also same reaction. Are you agreeing on? Yes, why? Because aqueous NaOH means it's becoming like Na plus plus OH minus. OH minus is acting as a nucleophile, is attacking on alkyl group. Then what happening? This bond will be breakdown. Br minus and Na plus is becoming like NaBr. After that, what we are getting? C2H5OH. That's why you have to write down one thing. Whenever alkyl halide will be treated with either aqueous KOH or nothing but aqueous NaOH, we are getting which compounds we are getting? Alcohols we are getting. A reaction going according to nucleophilic substitutional reactions. And I am giving another chemical property. You see carefully. Second chemical property, a very important for both point of view. It is nothing but Williamson's synthesis for ethers. Okay, synthesis means what? Preparation, but high quantity in that chemical reaction. That is specially calling as a synthesis, or otherwise just commonly calling as a reaction. In any reaction, we are getting a high quality or high quantity of the product, then the reaction is specially calling as a synthesis. Williamson did one reaction as a synthesis for the preparation of ethers. What is the statement you have to observe very carefully? You take alkyl halide. I will write statement first. Alkyl halide will be treated with the sodium salt of alcohol. Sodium salt of alcohols in presence of alcohol medium. In presence of alcohol medium, we are getting ethers. Yes. I think some new names is here. What is the statement for Williamson's? Whenever alkyl halide will be treated with sodium salt of alcohol in presence of alcohol medium, we are getting ethers. Okay, first of all, what is the meaning of sodium salt of alcohol? For example, what is the general formula of alcohol? ROH. Sodium salt, what has to be done? So in this alcohol, hydrogen atom is replaced with sodium atom, then we are getting RONA, we are getting, this is only we are calling as sodium salt of alcohol. And what is the meaning of ethers? What is the function of ethers? Just OR dash. So ethers means nothing but ROR dash. So this function group is calling as ethers. Okay, now what has to be taken? Alkyl halide, generally represented with RX. Okay, what is the representation of sodium salt of alcohol? You take Na, O and R will be there. R dash is not a matter. Means both the alkyl groups will be same or different. It's not a matter towards you. Okay, it will be treated in presence of which medium? Alcohol medium. What positive? This sodium will combine with the halogen atom, comes outside, like the NaCl, NaBr, like that. After that, R connected with the OR, we are getting which one? ROR, we are getting, those only we are calling as a ethers. Just can I give you one example for you? If you take CH3Cl, will be combining with sodium salt of methanol. Means sodium salt of methyl alcohol in presence of which medium? Alcohol medium. What happening? NaCl is eliminating. After that, what we are getting? CH3, OCH3. This only we are calling as ethers. Okay, just you see how the reaction will be going on. Just I will explain important how this total phenomena is going on according to nucleophilic substitution reaction. Just first of all, you see, you take the sodium salt of alcohol. What is that one? CH3ONA. It is breakdown. Which bond is breakdown? CO bond or ONA bond? ONA. Why? Because metal, non-metal, which is highly electronegative, oxygen. That's fine. The electron will be shifting like this. Then which species you are getting? CH3O minus plus Na plus. Now, which is a nucleophile? CH3O minus is considered as a nucleophile Nu minus. Now, sodium salt of alcohol will be treated with which one? Methyl chloride. Yes, you see very simple. CH3Cl. You know very well this gets partially negative charge, this gets partially positive. Positive charge is attracted by negative charge of nucleophile. Yes, you can take this one CH3O minus. This nucleophile is attacking on positive side, then this bond will be totally break down. Then connection to which one? OC connection. So then we are getting which one? CH3OCH3 plus which is coming outside? Cl minus is coming outside. Again Cl minus and Na plus is becoming like NaCl. Very simple. What is the statement for Williamson's? Whenever alkyl halide will be treated with sodium salt of alcohol in presence of alcohol medium, you are getting ethers.